Hello, and this time we're talking about sequences and just sort of a beginning introduction to all the different kinds of sequences that you might get in Key Stage 3, Key Stage 4 maths. Of course, there's loads of different sequences, and in fact, there's a really good website, the Online Encyclopedia of Integer Sequences, which has a huge catalogue of really weird and wonderful sequences made by all different methods, and there's a few number file videos that explain some of the interesting ones. But for your maths curriculum, there's just some nice basic sequences that we have to look at. And we can categorize them as arithmetic, geometric. Now, arithmetic sequences are ones where you add or take the same number each time. So, for example, that might be 2, 5, 8, 11, and so on and so forth. Here, to go from 2 to 5, you add 3, and then add another 3, and then add another 3, and the sequence progresses by getting 3 bigger each time. Now, you don't have to always add the same amount. You can have funny sequences where you don't always add the exact same amount. So Fibonacci sequence, for example, you start with 1, 1, or some people start with 0, 1, and you add the last two terms. So 1 and 1 gives you 2, 1 and 2 gives you 3, 2 and 3 gives you 5. Really good, really interesting sequence, but it's not arithmetic because you're not adding the same amount each time. And in fact, you can have sequences where you add an amount each time, but that amount changes. So maybe you have something like 2, 5, 10, 17. And here you've added 3, but here you've added 5, and here you've added 7. Well, it's pretty clear how to continue to find the next number in the sequence, or term of the sequence. It's adding 3, adding 5, adding 7, so this one's going to add 9. So you might see some of these, sequences where you're asked just to find the next few terms in the sequence where what's happening each time does change, but it will itself be a sequence that should be quite straightforward and quite obvious. But to be an arithmetic sequence, it has to be changing by the same amount each time, plus 3, plus 3, plus 3, or minus 2, minus 2, minus 2, etc., etc. For a geometric sequence, it's about multiplying or dividing by the same value each time. So this might start with 100 and then half and go to 50 and then to 25 and then 12.5 and so on and so forth. Each time it's going half, half, half the size of the previous, which makes it a geometric sequence. And I've also added these words down at the bottom because these are ways that we can describe sequences. An ascending sequence is one that just gets bigger. Now, if it's geometric, then it's going to get bigger as a curve because it's going to, if you're timesing by 2 each time, then it's going to get twice as big and twice as big. It's going to get the steepness of the curve is going to get greater each time, and this would be exponential growth, which we've heard a lot about recently with COVID. Arithmetic sequences that ascend are going to be linear. So sometimes you hear, well, it's supposed to be a straight line. Still not very good, but there we are. You might hear an arithmetic sequence being referred to as a linear sequence, and that's because it's going up by the same amount each time, like a staircase. Every time you step one to the right, it goes up by the same amount. So you get a straight line picture. And graphs that get bigger are called ascending. They're getting bigger. And descending refers to sequences that get smaller. So for geometric, it might be a sequence that halves and halves and halves. So it gets smaller and smaller. I still can't draw it properly because that should just get steadier, more flat, but never getting truly horizontal. And an arithmetic descending would be a straight line with a negative gradient going downhill. Now I've also put oscillating, because sometimes you can get things like that. You can get sequences that just oscillate back and forth between two numbers, like 1, minus 1, 1, minus 1, 1, minus 1, etc., etc. And if you've seen things like sine x, it doesn't matter if you haven't, but that's a sequence that oscillates back between two values. It's not really a sequence, but it's a function that oscillates between them. So in the maximums you get 1, there's minus 1, 1, minus 1. Of course it goes through all the numbers in between, but sort of the peaks and the troughs are just oscillating back and forth. Now you can have an oscillating sequence that gets bigger as well, or wider I should say, so a sort of an ascending sort of oscillating might look like this, where it oscillates back and forth, but all the peaks are getting higher and all the troughs are getting lower. Or you might have one that sort of contracts, so it starts off wide and gets narrower as it goes. Or you might just have one like sine, where it just stays the same amplitude the whole time. So let's just look at a couple of example sequences and just have a look at what they are. Or you might be asked in a situation like this to carry on the sequence for one term, two terms, or a few terms. In which case you just have to look at it and decide, is it arithmetic, is it geometric, or is it doing something a bit funny? So 3 to 9, I might look at that and think, okay, well, that's adding 6. And then look at the next term, or in between the next two terms, 9 to 15 is also adding 6. So I think we've got it. I think it's an arithmetic by adding 6. Add 6, add 6, yes. So we can now just carry it on, add 6, and add 6 again, and however many terms it wants us to do. For the second term, I'll do the same thing. 1 to 4 is plus 3, but plus 3 doesn't work here. So it's possible it's a weird and wonderful one, or it might be that it's a geometric and it's about timesing by 4. 1 times 4 is 4, but no, it puts a 9 in before the 16, so it's not timesing either. So let's have a look at the next add. 4 to 9 is add 5. Add 7. Right. So it's a bit of a funny one, this one, because the thing that you're adding on each time is changing. So it's not arithmetic, but we can work it out because the next thing will be plus 11 and then plus 13. So we'll get the answers 36 and 49. Here it's going down, so it's probably a subtraction arithmetic situation. Minus 6. Minus 6, minus 6, yeah, so it's taking away 6 each time. So we can just carry that on, take away 6, and take away 6. Here, 4 to 8, it's adding 4, but then it's not adding 4, it's adding 8, and then it's adding 16. So you might think this is one of these funny ones where it's adding a different amount, and yeah, you could think about it like that, but actually what's happening is 4 to 8, it's got twice as big. And then times by 2, times by 2, times by 2. This is a geometric sequence. It's doubling each time. So we can just double that, 1, 2, 8, and double that, 2, 5, 6, for the next terms in that sequence. And likewise, this last one is geometric as well, but this time instead of timesing, it's dividing. It's losing a 0 each time, so it's being divided by 10. So it's coming down 5,555 divided by 10. You could either write it as 0.5 and then 0.05, or you could write it as 5 over 10 and 5 over 100, depending on whether you prefer decimals or fractions. So hopefully that just gives you an idea of different types of sequences that you might see and how to look at them and say, well, is it geometric? Is it arithmetic? Is it going up by a funny sort of changing amount each time? And then once you've got that rule, you can find the next term, the next number in the sequence, by just applying that same rule. Or if it is a funny one where the rule changes, by working out the next thing that you add on, and then the next one, and applying that. If you have any questions or comments, pop them down below. Otherwise, ta-ra for now.